We're going to look at some functions, different, variables, and a bunch of different things in lesson 94. The first one we're going to look at, let's just look at example one, and we'll kind of look at the terms and the terminology as we do the problem. 94.1 example says, which of the following depict a function? Okay. A function is simply a set of ordered pairs in which no two pairs have the same first element and different second element. For example, if you have y equals x minus 5, okay, well then y and x can only be one set of numbers, for example. So say it was, I don't know, okay, 10 is y, and then x is 15, right? All right. So 10 is y, x equals 15. All right. So this right here would work. So if 10 is y, x can be nothing but 15. So x cannot be 10, right? Because that would be 5 equals 10, and that wouldn't work. So it only has one solution of answers when y is 10. Now I can have different solutions. I could have y equals 20 and x equals 25, right? That would work as well. So that's another function. But if y is 20, x can only be 25, and that's what it's saying. So it wants to know if we can have now the key is the range, all right? The range, each answer has to have a number. I don't want you to get confused by my domain and range because of my problem that I just wrote down. Whatever the equation is, it could be y equals x plus 2. You have a bunch of different stuff. Different things could work. You x squared, square root of y, different things like that. So there's a bunch of different stuff. Point being, each number in the domain needs an answer in the range, but it can only have one. So it wants to know if this is a function. Well, because my two numbers in the domain, 4 and 3, both have one answer of 3, yes, that would be a domain. Okay? Each part of the domain can only have one answer. All right? In part B, it gives 7 going to 3, and then 5 goes to 3 and 4. Well, 5 cannot have two answers with it. So therefore, that would not be a domain. A function. It's not a function. Part C, 4 has 5, 6 has 7, but it doesn't give any part with M. So because it doesn't have a solution with it, that is not a function. Now D says any real number that's plugged in for the equation y equals x plus 2. So basically, since any real numbers can be plugged in for there, just know that that can be a function. So I know it's confusing, and just ask questions in class and we can solve any questions there. But that's the general premises of domain and range. Now looking at ordered pairs, example 2. It wants to know which of these can be a function. Once again, you can't have, so I could not have the same x value, right? My x value cannot be the same. So 4, 7, -3, -6 are all different. So therefore, boom, it's a function. 4, 5, 7, 6, those are all different in my x values. That's a function. 5, 4, 7, 5. So we have 2 5s, so that is not a function. And then last one, 7, 3, 6, and 4, all different. Yes, that's a function. So that's how you determine if ordered pairs are a function. Very simple, just look at the x values in the row. It looks like a lot. It's really nothing complicated, just different. Now looking at example 3, using different, the functions, domains, the terminology. Let's just talk about the algebra side of it right now. the math part of it. It says if h of x equals 4x minus 3 and p of x equals x squared minus 3x, find p of negative 3. Okay, well what does that mean? How do we do that? Well, if it says p of negative 3, well what that simply means, okay, it says p of x, this is just telling me what my x is. It's negative 3. So now for my equation of p of x, I can plug in for x squared negative 3 minus 3 times negative 3. I cannot do it for h of x. So we're going to ignore this one because we can't solve for it. It didn't give us what h of x is. But I can solve for p of x, so we do negative 3 squared, in parentheses, 9. That's a positive 9 as well. So p of negative 3, or when p of x is negative 3, it would equal a positive 18. And that's all you do. You're just basically plugging in for x, and that's how you do different functions and domains.